This episode of Lex Out Loud is brought to you by the patrons of Starwalker Studios. Learn how you can support the show at lexstarwalker.com/support. Hello and welcome to episode 36 of Lex Out Loud, Writing Science Fiction. I'm your host, Lex Starwalker. This is a podcast for writers, readers, and all lovers of speculative fiction. I'm writing my third novel and taking you along for the ride. So welcome back, everyone. Welcome to Lex Out Loud. So glad that you joined me today. So today I'm going to take a break from the Writing Groups series and talk a little bit about space tourism. So it was a couple days ago now, I was sitting and watching the Inspiration 4 launch and really enjoying that. I hope you saw it if you wanted to. If not, you can still see it. I'm sure you can go watch it on YouTube. There was a few different places you could see it. Basically, it looked like everyone was using SpaceX's footage. So you can go watch it on SpaceX's YouTube channel. Netflix had coverage on their YouTube channel with some fairly well-known hosts and whatnot. And I enjoyed some of the programming up until the launch. I mean, it was very commercialized, but when it came time for the actual launch, I actually went over to the SpaceX stream because I don't know. I just really hope in the future, when SpaceX is a lot bigger and doing even more, I really hope that they keep doing their own media because, yeah, maybe it wasn't quite as polished as what Netflix/Time did, but it also wasn't nearly as hokey or fake seeming. It was much more genuine and gave you more of the feeling of being there with them for it. And also more informative. SpaceX does a really great job while they're waiting for a launch, explaining the mission, explaining the different phases of the launch itself, and all of that. So, I get that the Netflix/Time one maybe was better for just average people that don't really pay attention to this stuff. But for those of us that are rocket nerds and whatnot, the SpaceX channel is really where you want to be. That's where the best coverage is, in my opinion. But anyway, I was watching it the other day and they were launching. They were on their way up to orbit. And I realized as I was watching this, that I'm like, this is one of those turning points. This is a moment in history where things could go at least a couple different ways. And depending which way things go, we could have very, very different outcomes. If this mission is successful, then I think it makes the kind of future I'm envisioning for my books much more likely and more likely to happen sooner as opposed to later. Where if this mission isn't successful, I think it could very easily have the opposite effect and kind of set us back a bit. So hopefully it's successful. So far, everything's going great. And yeah, so I thought, while I was watching this, I thought this would be a fun thing to talk about today. For one thing, I really miss nerding out about space stuff on the show. It's been a while. Back in season 1, when I was talking more about world building, I did a whole bunch of episodes just all about what I called the future history of Earth, where I was developing the timeline, kind of figuring out what are the big happenings as far as space exploration between now, the current day, and about 200 years from now when my story takes place, and figuring out, what all that looked like. And I had a lot of fun doing that. I did a lot of research doing that. And I shared a lot of what I learned with you on the show. So if you're a new listener and you haven't heard those and that sounds interesting, definitely go check out season 1 and all the various world building episodes. But I haven't talked about that kind of stuff for a while on here, and I kind of miss it. sometimes my wife will watch launches with me, and she's a very good sport to hear me go on about this stuff. But I don't think she's nearly as excited about it as I am, which is fine. But sometimes it's fun to talk with someone who's as excited as you are about something. So if you don't know what the Inspiration 4 mission is, I would think that everyone knows what that is. At least everyone here in the U.S. Now, I don't know in other countries, how much coverage there is of this. I mean, I would guess in Canada and Europe, at least, it's pretty well covered, but I don't know. But just in case anyone's not up to speed, Inspiration 4 is a mission that's being done by SpaceX where they are launching 4 civilians into Earth orbit, and they're going to be in orbit for 3 days. So this is the first ever mission into space that is crewed 100% by civilians. None of them are professional astronauts. Now, civilians have gone into space before this quite a few times. Mission specialists on various missions, as well as other non-professional astronaut people have gone into space, have visited the International Space Station and things like that. However, before this, all missions included at least some professional astronauts. And, just again, I'm sure everyone knows this, but at least here in the US, I think it's true everywhere that has astronauts. So I'll just say anywhere. Astronauts are the best of the best. They are physically, pretty much perfect, or as perfect as anyone can be. They're in peak physical condition. Mentally, they are well above average intelligence. They're some of the brightest people on the planet, some of the best in their field, whatever a given astronaut's field is. Psychologically, they're very stable and able to endure hardships that a lot of us could not, and still keep their cool and still be professional and still get the job done. So in so many ways, astronauts are not average everyday people. They are the best of us. So that's one of the things that's exciting and important about this mission is for the first time, we have a group of people going up into space that are all civilians, that none of them are professional astronauts. And yes, it turns out that these are remarkable people, but I mean, really, what is an average person? Really, everyone's remarkable in their own way. But they went through, I think it was 8 months of training, as opposed to, years of training that astronauts usually go to. And, they have very different backgrounds than what we've seen from professional astronauts. So it's a lot closer to someone like me or you going to space than, most of the people that have gone up to space up to this point. So this shows the viability of just an average person going to space with some training, of course, but someone who isn't necessarily in perfect physical condition. Also, they're not just passengers. They're not just going on a joyride. I personally took a little issue with the people that rode on the Blue Origin suborbital flight and the Virgin Galactic suborbital flight. I kind of took issue with those people calling themselves astronauts. Now, I'm not the one that decides what these terms mean, obviously, but to me, they were not astronauts. They were passengers. They weren't part of the crew. The Blue Origin flight was completely automated, and the Virgin Galactic flight, they had pilots, but it wasn't the people that were on the news were passengers. They were not crew members, and that's a huge difference. Well, these people on Inspiration 4, they are the crew. They are the only ones up there, just 4 civilians. So that's a huge difference compared to what Virgin Galactic and what Blue Origin has done. They are full crew members, not just passengers. Also, this isn't a suborbital flight. Both Virgin Galactic and Blue Origin's flights were suborbital, which means they did not go high enough and they were not going fast enough to enter orbit. And, for any of you that don't know a lot about rocket stuff, the difference between going as high as what Virgin Galactic and Blue Origin went and going as fast as they went, the difference between that and actually going into orbit is huge. It's an order of magnitude more difficult and more expensive. Takes a lot more energy. You have to be going a lot faster. So it's a big deal. The difference between suborbital versus orbital is a huge deal. So Virgin Galactic and Blue Origin flights were suborbital. They did not go anywhere near low Earth orbit. So the Inspiration 4 mission is going into orbit. And on top of that, they are in a higher orbit than both the International Space Station and the Hubble. So this is the first time humans have gone that high up in quite some time. I think it's a number of years. I don't remember the exact figure, but I think it was like 2 or 3 years or something like that it's been since someone's actually gone up that high. Probably the last time we serviced the Hubble, whenever that was. So they're going to be in orbit in a microgravity environment for 3 days. Now, this is compared with the Virgin Galactic and Blue Origin flights, in which the microgravity was only for a few minutes. So huge, huge differences. This is just on a whole nother level than anything we've seen before as far as space tourism or civilians, non-professional astronauts going into space. One of the crew members is a cancer survivor. She had cancer at a young age and bone cancer, if I remember right, and was treated and recovered. She was treated at St. Jude's and has since become, I believe she's a physician's assistant at St. Jude's, and she has a prosthetic in her leg. So she is the first person with a prosthetic ever to go into space. And, they're not just on a joyride. So many times in the media, you'll hear people kind of talking it down about these flights, whether it's Blue Origin or Virgin Galactic or SpaceX, and just saying, they're just going on joyrides. Well, it's not just that. They're doing science too. Even the Virgin Galactic and the Blue Origin flights, there was science involved with those too. And even if on a given flight there aren't any experiments being run, data is still collected. Data on the physiology of the crew members and the effects of launch and weightlessness and re-entry on them, the effects of the G-forces on them, all those kinds of things. Every time one of these flights happens, we get more information, we get more data. Also, in the process of all this, they managed to raise a decent amount of money for St. Jude's for cancer research. So that's a good thing too. So like I said, I was watching this launch and realized that I was in one of these turning points in history, which I feel like this is maybe the first time in my life that I've been in one of those moments and realized it at the time. And it was kind of a surreal feeling in a way. So with the success of this mission, I think it greatly increases the likelihood that we will one day see a future like the one that I and so many other science fiction authors are writing about and dreaming about. I mean, true, this still isn't something just anyone can do. You or I can't just decide that we're going to go into space. When they start selling tickets on even, the Virgin Galactic or Blue Origin systems, which again are just suborbital, but even those, when they start actually selling tickets, they're likely to be in the hundreds of thousands of dollars to start with. So, and still not something just anybody can do at the drop of a hat. However, we are bringing down the cost to get to low Earth orbit all the time, thanks in a large degree to SpaceX and other companies that are working on getting to orbit more efficiently and more cheaply. Now, I've talked about this a lot in some of those world building episodes that I mentioned before, but as the cost to get things in the orbit continues to go down, and as more and more companies get involved in space tourism and compete with one another, this is going to make spaceflight continue to get more and more affordable as time goes on. And as that happens, it will be available to more and more people as that price tag just keeps going down and down. You can draw some parallels here to the airline industry. So in the beginning, when the airlines first started, plane tickets were really expensive. And for the most part, it was only the rich and business people who could afford to fly. Nowadays, many people can afford to fly, and many people do fly, not just people on business trips and not just wealthy people, but just all kinds of people are able to fly now because the price of those tickets have come down dramatically from when the commercial aviation industry first started. So the same kind of thing is going to happen with going into space. As it becomes more commercialized, as more and more companies become involved, as more and more companies compete, as more and more consumers become interested in the service that they provide, they will find more and more efficient ways to do things, and things will get cheaper and cheaper as we go. So this isn't really about people taking vacations in space. I mean, when you talk about space tourism, that's what we're talking about, right? We're talking about a vacation or a joyride. You know, someone gets on a rocket and they shoot up, on a suborbital flight. They experience a few minutes of 0G and they come back and, snap some pictures, come back, tell their friends about it. Or someone goes up into orbit on a space station in a space hotel for a few days and spends a lot of money and spends some time up in orbit looking at the Earth, being in weightlessness, that kind of thing. A vacation, right? A joyride, that kind of thing. Like that's what space tourism is. That's what it's promising us. But there's so much more to it than that. There's a lot more that can be done commercially with space travel than just vacations and joyrides. For instance, we can have commercial space stations that can be used for research and for construction up in space. And there are already plans for these. There are already companies planning to build their own space stations, their own privately owned space stations. And then they could lease out space to scientists to run experiments, to companies to build or test products, all kinds of stuff. There's also a lot of other stuff we could do in space. For instance, we could commercially gather resources from the moon. There's all kinds of stuff on the moon that we could use in space. Metals like aluminum and titanium, silicon for making plastic or glass, water for, water. And also you can split that into hydrogen and oxygen. Hydrogen's your rocket fuel. Oxygen's your oxidizer. Also, oxygen is nice to breathe. We can get all these things from the moon. Eventually, we can commercially mine asteroids. And we don't need to go all the way out to the asteroid belt between Earth and Mars to do that. There are asteroids closer to Earth called near-Earth asteroids that are as close as the moon or even closer than the moon. We can find all kinds of metals, rare and otherwise, as well as rare earth elements from asteroids. Things that are very difficult to find or mine on Earth, that are in limited quantity on Earth, and also things that are very destructive to the Earth to mine. We don't have to worry about destroying an asteroid when we mine it. We don't have to worry about environmental impact on an asteroid when we mine it like we do here on Earth. Now, there is a lot of infrastructure that we need to build in low Earth orbit and other orbits, as well as at the Earth, Moon, L1, Lagrange point, and in lunar orbit to really be able to realize this potential. So if we had the needed infrastructure in orbit, in space, it would be far cheaper and easier to get the materials that we need to build a space station or to build a spaceship from the moon. Even if we're going to build the thing in Earth orbit, it would be cheaper to get the materials from the moon and move them to Earth orbit and build the thing in Earth orbit than it would be to get the materials from Earth and launch them in orbit. That's how much energy it takes to get out of Earth's gravity well. Even though the moon is so far away, it doesn't really take a whole lot of energy to move something from the moon's orbit to Earth's orbit. Not compared to what it would take to move that thing from the surface of Earth up into Earth orbit. But the reason we can't do that right now is we don't have the infrastructure. Now, there are plans underway, plans for the Gateway Station in orbit around the moon, the Artemis program planning to establish a base on the surface of the moon. These are the beginning steps to starting to build that infrastructure. And in addition to being able to get resources from space, from places like the moon and asteroids, we also need to be able to fabricate things in space. Right now, everything that we put up into space is built here on Earth on the ground, and then it's launched into space. So the size that we can make things like space stations or other space facilities is inherently limited by the size of the rockets that we have. So for instance, if you think of the International Space Station, the International Space Station is made up of a bunch of different modules, a bunch of different pieces that were launched independently on rockets and then fit together in orbit. The different pieces were connected together in orbit. However, each one of those pieces could only be as big as what could fit in the rocket that was launching them. Or in the case of most of this stuff, I think it was actually the space shuttle that was taking the stuff up. So they couldn't build a section of the space station that was bigger than what they could fit in the cargo bay of the space shuttle. So that's a limitation right there. So, you look at the International Space Station and the diameter of it. I mean, we can't really make it bigger until we have bigger rockets that can carry up bigger diameter sections. So, I like to talk on this show about rotational gravity and how we need to get to the point where we can have space stations that rotate and produce Earth gravity. And, they have to be big. If you want to avoid spinning people like a top and they're losing their cookies all the time, you have to make the thing really big so it can spin more slowly to produce the gravity that you want. And there's no way we could build anything like that right now because you could never make a rocket big enough to launch something like that. So really the only way we can go much farther than we have now is we need the ability to be able to build things in space, to fabricate them in space. Because, like I said, right now we can't launch any component to build a space station or anything else into space that is larger diameter than the rocket or the fairing of the rocket that's carrying it. Now, this will get a little better with Starship because Starship's pretty big, but still, it's still going to be a limitation, and it's not that much bigger. It's still nowhere big enough that you could have something that spins for gravity. In addition to just that limitation on size, when you're talking about launching things in orbit, it also, costs a lot of money to lift all that weight into orbit. And like I said, once we have the infrastructure in place, it will be a lot cheaper to get whatever materials we can from the moon or from an asteroid and bring that over to orbit to build things around Earth than it would be to lift them up from the surface of Earth. Also, the launch process itself is really hard on the hardware that we send up. There's a tremendous amount of vibrations that they go through during launch, as well as a tremendous amount of noise. And so everything that we send up has to be hardened and has to be engineered in such a way that it can withstand the G-forces of the launch and the vibrations of the launch and the noise of the launch, all of which makes it more difficult to engineer, more difficult to build, and a lot more expensive, and introduces a lot more points of failure, a lot more things that can go wrong. Add to that, we build things that, trying to get past this size limitation of our rocket fairings, a lot of times we'll send up things that expand. For instance, the James Webb Space Telescope, which is launching, I think sometime in November. There have recently been quite a few images shared on Twitter and whatnot as they've been packing this thing up for launch. And you've got this huge telescope that, kind of like a transformer, is packed down into this much smaller package that can fit in the rocket. And then it has to endure all those forces of launch I just talked about. And then once it's up in orbit where it needs to be, all of that stuff, the solar panels and the heat radiators or whatever it is, all of this stuff, it has to transform from its pack shape. Everything has to unfold, and that's all automated. And, all that stuff went through launch, and now it's in the vacuum of space. And, all that has to work perfectly, or your billions of dollars telescope isn't going to do much if it can't unpack. So if you can build the thing in orbit, you don't have to deal with any of that. And again, making these things so that they can fold up and unfold automatically, robotically, adds a lot to the development cost and time and to just the cost to build the thing and to test it. So if we can build things up in space, up in orbit, they don't have to be built to withstand the forces of launch. They don't even have to be built to withstand Earth gravity. And they don't have to be built to be able to be packed into a rocket fairing and then be able to automatically deploy themselves and unfold or whatever they need to do to get to their full size. So this means we could both build bigger things and build them cheaper. Also, there's the fact that some construction will just be a lot easier to do in a weightless environment in orbit in space than it would be here on Earth, where you have to deal with gravity. Some construction is only possible in a weightless environment. I saw a thing recently, I think I talked about it a little on the show, where there's a company that's developing a superior form of fiber optic cable that can handle much higher bandwidth than the fiber optic cable we have now, but you can only manufacture it in zero gravity. You can't make it in a gravity field. And there's lots of things like that could be done in a microgravity environment that are impossible on Earth. Things we could make, things we could build, stuff like that, products we could create. So having the infrastructure that we need in space will make everything that we do in the future more possible, easier, and cheaper to do. So for example, if we were going to send people to Mars, right now we would need to launch all of the hardware for that and all of the fuel for that from the surface of Earth, which would take a tremendous amount of energy and money. However, once this infrastructure I'm talking about is in place, we could make fuel on the moon from lunar resources. We could get the fuel from moon to Earth orbit to fuel the Mars ship. And we could even build the Mars ship itself in orbit. All of that would be a lot cheaper than having to lift all that up from Earth. And again, part of the reason of that is the moon's gravity is only 1/6 that of Earth. So it takes 6 times the energy to move a weight in the orbit from the Earth than it does from the moon. So to make these things happen, to make this a reality, there's a lot that needs to be done between now and then. A lot of groundwork to be laid and a lot of money to be spent. So one of the big benefits of missions like Inspiration 4 is getting the public excited about space and space travel. You know, we will never be able to do any of this. We'll never be able to establish this kind of infrastructure in space without the support of the general public. Also, I think a very important part of this is I don't think you can overstate the importance of someone having the low Earth orbit experience of seeing the Earth in its entirety from that distance. Everyone's changed by it. People come back caring more about the planet and about humanity, seeing us as one race, one people. They realize how precious the time, resources, and opportunities they have are, and how important it is to use those to better the planet for all of us. So every time someone has this experience for the first time, the world becomes a little bit of a better place. Personally, I think and hope that in the future, world leaders, for instance, here in the US, the president, all members of the House and Senate, the Supreme Court, etc., when they're elected or appointed, they should have to go to low Earth orbit and spend an hour or so in orbit and get this perspective of the Earth. I think every leader in every country should have to do that. I think it would greatly improve the situation for the rest of us. So that's all one side of this. Another side of this is becoming a multiplanetary species is really, really important. It's vital. This can't be overstated. You cannot overstate how important this is. Right now, a lot of people probably don't realize, but we are really vulnerable right now. A single asteroid impact on the order of the one that took out the dinosaurs would wipe us all out. We'd be gone. The great human experiment would be over. And no one would ever know we were here. We might not even need something as drastic as an asteroid or a comet impact to wipe us out. We might do it ourselves through the climate change we're bringing about if we don't make a lot of major changes yesterday, which, let's face it, doesn't look like it's going to happen, does it? It's not looking good. Every place that we can have people living other than on Earth decreases the odds of a single calamity event wiping out the entire species. Orbital stations, cylinders, baby. I guess we can start with some toruses to begin with, a little smaller, and then go up to cylinders. But orbital stations around Earth, around the moon, around near-Earth asteroids, around Mars, etc. Kind of like the setting I've come up with. That's what we need. Now, people love to talk about building a base on Mars, and something that seems to be constantly overlooked with that is Mars only has 1/3 the gravity of Earth. So a lot more research is needed into this as far as what are the long-term effects of living in less than Earth gravity. We have some idea of the effects of living in microgravity from people on the ISS, but we really don't have much idea of how would living in 1/3 Earth gravity compare to microgravity or compare to Earth gravity. But for right now, the safe assumption is that you will need Earth gravity for any kind of long-term settlement where people are living there long-term to be viable. And that's not possible on Mars. There's only 1/3 gravity. So what will really happen, if there are cities on Mars, they're not going to be under domes on the surface of Mars. They will be in rotating habitats in orbit of Mars. I wish more people realized this, but maybe we'll get there soon. In addition to all of this, development of space technology has the potential to solve a lot of our problems here on Earth. For instance, space solar power satellites could provide nearly limitless green energy to Earth and all of our inner solar system settlements. There's a lot of potential there. That's just one example. Development of efficient fusion technology would also help a lot with our energy woes, as well as the environmental impacts of our energy production. The development of moon and asteroid mining will provide a lot of benefits. Not only will we have access to a lot more resources than we have here on Earth, we'll be able to mine them all we want without doing any environmental damage to the Earth whatsoever. In the future, I imagine everything that can be harvested in space probably will be, as opposed to harvesting from Earth and doing further damage to it. In the future, we could do various types of testing of new technologies and whatnot that would be harmful to the environment. We can do those in space somewhere instead of on Earth. I mean, wouldn't it have been nice, when they were doing all the nuclear bomb testing and they blew up all those nuclear bombs here on Earth? I think this still happens in other countries as they develop nuclear capabilities. Wouldn't it be great if all those nuclear weapons, instead of being detonated in our backyard and filling our home planet with radiation, if they could do that out on an asteroid somewhere where no one cares? Wouldn't that be great? Being able to build habitats with full Earth gravity will allow us to grow our population all that we want without straining the resources of Earth, because there will be plenty of space to put people, there will be plenty of energy, and there'll be plenty of food, because you can grow food on those things too. Speaking of which, in the future, we can grow our crops in space, eliminating the hugely negative impact on Earth's environment of growing just a handful of plants all over the place, which is what we have now. It's really, really bad for the environment. So I think at a certain point in the future, most, if not all food, especially your cereal grains and things like that, where you just need acres and acres and acres of the same thing, that'll all be grown in space. Also, once you have one of these cylinder habitats going, you can completely control that environment in a way that you can't on Earth. So you can give the plants the perfect gravity, the perfect humidity, the perfect atmospheric pressure, the perfect, amount of CO2, whatever. You can control all of that. So once we can build these big orbital habitats in space, they will allow us to effectively grow our population forever without limits, and do that without straining the Earth or damaging it or depleting its resources. So when you hear people ask, well, why should we care about billionaires going into space? Or why should we care about this Inspiration 4 mission? Well, I just gave you a bunch of reasons why. Because it makes all these things more imminent, more likely to happen. It gets people excited about space. Because, that infrastructure I talk about, creating facilities in orbit of Earth where we can fabricate space stations, where we can fabricate spaceships, creating facilities on the moon, in an orbit of the moon, where we can harvest resources from the moon and bring them to Earth. The same on near-Earth asteroids. All of that is going to take a tremendous amount of money and will and drive to accomplish. And like I said, there is no way that we'll be able to do it if the general public is not on board with that. If, 90% of people in the US or whatever country you're talking about are opposed to spending money on that kind of stuff, it's either not going to happen or it's going to happen much, much more slowly. If, on the other hand, the majority of people in the society understand the benefits and understand where this can take us, and they're excited about that, then not only can we do it, but we will do it, and a lot more quickly than we think, probably. At the end of the day, it really comes down to, how much money are people wanting to put toward this? How much money is the government willing to put towards it? How much money are private companies willing to put towards it? How much money are private citizens willing to put towards it? And if that answer is nothing or close to it, then we're not going to get anywhere very fast. But if most people see that as something that's important and something that deserves resources put towards it, then it will be. It's kind of funny. Anytime you see an interview with Elon Musk or Richard Branson or Jeff Bezos about space tourism or about what they're doing, they almost always ask the question, well, what would you say to the people who say, oh, we should be worried about problems here on Earth and not sending people up into space? What would you say to those people? And I've heard them all field that question different times, but I just heard it again in the kind of the stuff they were showing before the Inspiration 4 launch. And I thought Elon Musk had a really great answer for that. And basically, in a nutshell, what he said is that, yes, we should be focused on problems here on Earth, and maybe we devote 99% of our resources to that. He's just suggesting that we take 1% or even less than 1% of our resources and devote it to space infrastructure and things like what I've been talking about, which would still be a significant amount of money. And I think even more important than the actual dollar amount would be that commitment of, we are saying we're going to dedicate this percentage of our resources to developing this, and we see that as worthwhile. That'll be a huge step in the right direction, I think. So yeah, at the end of the day, I want to see this future because I think it would be cool and awesome, and it's the kind of world I would want to live in. It's the kind of world I wish I lived in, the setting that I've created for my book. But it's not just that. That's very selfish in a way. It's also, it would just be a better world for everyone, and especially for those that have it the worst right now. Maybe for the billionaires, it won't be that big of a difference, but for the rest of us, it would be a much better world, especially for those who are even far less fortunate than what I am, and probably what everyone listening to this podcast is. In a future where there is unlimited energy and resources, everybody will be lifted up. The tide rises all boats, or whatever they say. So that's why this stuff is exciting. Yeah, true. Nobody cares about Elon Musk or Jeff Bezos or Richard Branson going up in space. I think we can all agree nobody cares. Or about any other billionaire or millionaire taking their joyride and getting their kicks. Nobody cares about that. We all agree. Nobody out there thinks that anybody cares about that. But that's not what this is about. The way I look at it is, there are a lot of people out there with a lot of money. What are most of them doing with it? At least these guys are doing something constructive with some of their money. Well, at least Richard Branson and Elon Musk. I don't see Jeff Bezos as being very constructive right now. I feel like any good he's done has been more than outweighed by holding up the Artemis program and all that nonsense. But that's another topic. But finally, there's another reason that this makes me really excited. And this is a much more personal reason. But I think it's one that anyone my age or older who is excited about space exploration will probably recognize. I remember hearing about the moon missions my entire life growing up. Last moon landing was in 72, so that was before my time. So yeah, I was unfortunately born after all that, so I didn't get to see any of the Apollo missions live, but I grew up hearing about them, learning about them. I grew up during the shuttle program. I saw the Mars rovers go to Mars, all that good stuff. But I also was there for the shutting down of the shuttle program and the whole lot of nothing that came after that as far as human space flight here in the US. And it was a super discouraging time for me. It's not something I think about a lot, but it was actually kind of a big deal and something that only now I think do I realize how big of a deal it was, because as a kid, I was super into space. I watched Star Trek all the time. Anytime we went on a vacation, if there was an airplane museum or a space museum or anything like that, like we always had to go. I saw the Kennedy Space Center. I had space magazines. I remember I had a subscription to the Smithsonian Air and Space magazine, like all through from whenever that magazine launched, because I remember when it first came out, I got it and I had it all through high school. I watch or listen or read anything space related I could find. And I just couldn't get enough of it. And I was so excited. I thought, someday we're going to go back to the moon. Someday we're going to go to Mars, blah, 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 blah. And then they shuttered this shuttle program. And I just got really discouraged. And I was like, and kind of the sentiment at that time was, we're kind of going nowhere fast. And people started talking about how long it'd been since we'd been to the moon. For all this time, we'd just been going up in the low Earth orbit. And then they shut down their shuttle program with no replacement. I mean, I remember them talking about the SLS way back then. I don't think they called it that then, but I remember them talking about it. But it just went nowhere for a long time. And I got really discouraged to the point that I stopped paying attention to it. And, fast forward years, decades, and it was really hearing about what SpaceX was planning. And when they started testing their Falcon rocket, that I started getting excited about this stuff again. Because I just gotten so discouraged that I was just like, this isn't going to happen in my lifetime. So why waste time dreaming about something that is never gonna happen? But now the dream's alive again. Thanks mainly, I think, to SpaceX, at least in my opinion. That's what's had me excited for the past few years is what they're doing. And, now we're seeing other companies doing everything from launching rockets in orbit to take satellites in orbit to working on exploring the moon for mining, to working on space hotels, to working on space construction. If you're in our Discord server, I've posted articles about all this stuff, all this amazing stuff going on right now in the private sector. And it's a new space race. Is that what they call it? Space 2.0. It's happening again, finally. So I'm really excited because I remember that long wasteland of years where there was not really anything going on as far as human spaceflight from the US. And it took private individuals like Elon Musk to get us there again. And, in addition to the great strides SpaceX has made in proving the viability of reusable rockets, which before they did it, everybody thought was impossible, and already greatly reducing the cost to get a kilogram in orbit. And that cost continues to go down and will go down even more with the Starship once that's operational. In addition to all that, and just as important, I think, is they've gotten people excited about it again. Lots of people go and watch these launches. They'll go and watch SpaceX launch a bunch of Starlink satellites or go watch a supply mission to the ISS or one of these crewed missions that they do. It's in the public consciousness again. People are getting excited again, not just people like me. So it's pretty cool. It's an exciting time. It makes me hopeful for the future and excited to see what comes next, which is really amazing and wonderful in this time where pretty much everything else in the world is discouraging and seeming like we're just racing to see how quickly we can destroy ourselves. Between war and pandemics and natural disasters from climate change, it's like, how are we going to kill ourselves first? Who's going to win the race to the bottom? It's what it feels like. So this new golden age in space exploration is like the one shining light in all that darkness for me. It's the one sign that maybe there is some hope for us as a species, that maybe somehow, against all the odds, we will get through this time and continue to evolve and flourish and exist far into the future. So I hope that's true. But yeah, so that's why I'm excited. That's why I think this stuff is expensive. That's why I think this stuff is important. It is very expensive. And that's part of the problem. But that's why I think this stuff is important. And it's got nothing to do with billionaires getting their kicks. Nobody cares about that except the billionaires. Nobody else cares. So, to all the journalists out there asking those questions and writing those headlines, nobody cares about that. You don't have to worry. Nobody cares about the billionaires. That's not what it's about. And honestly, we're lucky to have them as far as that goes. Someone had to do it. And who else has the means? So I'm just glad of the billionaires out there that at least a few of them decided to try to do something worthwhile with, all that money they probably shouldn't have. But yeah. So yeah, I'm excited and looking forward to seeing how this goes, what comes next. I'm really looking forward to seeing the first space hotel in orbit. I'm really looking forward to seeing the first private, commercial, non-government space station in orbit. Yeah. So one more thing. I want to plug a podcast I really enjoy. If you find this kind of stuff interesting, and if you would like to stay up to date on what's going on as far as our exploration of the solar system, I highly recommend the podcast Planetary Radio put out by the Planetary Society. And they'll keep you up to date on all that's going on. It is a little dry. So if you're not like into this kind of thing, it's probably not going to be for you. But if you are fascinated by, the James Webb Space Telescope and the various robots we have on Mars and the future missions planned for Venus and things like that, it's a great way to kind of keep up on what's going on and get the highlights so that you can go read up on stuff that you want to learn more about. So I highly recommend it. I'll put a link to it in the show notes, but it's at Planetary. Is it? I think it's just planetary.org, or is it? Yeah, it's at planetary.org/radio, which I think it is on the radio. So if you have like satellite radio, I think it's on some station somewhere, or maybe it's on public radio. I don't know. But I think they are on the radio too. But my God, I haven't listened to a radio in probably close to 20 years. Technology has moved on. All right. Well, I think that's enough. But I just really wanted to talk about this today and kind of share this moment with you because, I think this passed a lot of people by. As much attention as it did get, I think there's a lot of people out there that had no idea this was even happening, and it's a really big deal. So if you were one of those people, now you know about it. And also, if you were one of those people that was wondering why we should care about this or why this matters, hopefully I've made a good case for why it does matter and why it's actually really, really important. And one of the more important things that we as a species are doing right now. building for the future. For so long, we have been, as a species, living in the present and exploiting the future for the present. And now we are finally starting to see the consequences of that through climate change and everything that's happening. All these generations who ignored the scientists telling them about the damage we were doing to the planet because they wanted to make more money. We are now living with the consequences of their choices and their actions and their inactions. And as much as we are suffering for it, the coming generations are going to suffer much more. It's going to get a lot worse before it gets better, if it gets better. So I hope it does. I have a lot of faith in the new generations coming up. There's a lot of smart people coming of age these days. And hopefully they will learn from their elders' mistakes and take us onto a better path into the future. So that's going to wrap it up for me today. Let me check my schedule here. What's coming up next time? I think actually I'm taking another episode off before, actually episode 37, I'm still not sure exactly what I'm going to do for that, but I'm going to do something a little different, I think, for episode 37. And then episode 38, we'll get back to talking about critiquing. So, if you have any ideas or tips or thoughts about either giving or receiving critiques as a writer, let me know. And maybe I can bring some of that into that discussion. If you'd like to reach me, you can email me at lexoutloudpodcast@gmail.com. You can follow me on Twitter @LexStarWalker, and you can call my voicemail 951-465-5391. And finally, we do have a Discord server that you can join and talk with us there. And you can find a link to that as well as any other links in the show notes at lexstarwalker.com/LOL. All right. Well, I hope you have a great week and best of luck with whatever you're working on, if anything. And until next time, keep writing.